everyone, I'm Stephanie. Today I'm going to talk about genetic engineering, about cows that pass less gas. So let's get right into the topic. Global warming has been a serious problem in recent decades. Earth is getting hotter and hotter. Let's look at this graph. A temperature anomaly is a difference from an average temperature. Starting with 1940, the annual temperature is going beyond the average temperature, which shows that the temperature is getting abnormally high. And starting with 1960, the line is going up, which clearly indicates that the average global temperature is increasing in recent years. So, why did I choose this topic? Look at the picture. Air pollution, emission of CO2, cows' farts, all leads to greenhouse gases. Having a solution to cows' farts seems to be an interesting topic, and cows can save the world. Well, at least slow down the rate of global warming. So in this research, I would like to find out the answers of these questions. So I talked about why I chose this topic, but why does people want to do this? Basically, the answer is the same, to reduce the emission of methane produced by cows, in order to slow down the rate of global warming. Greenhouse gases trap heat in the atmosphere, which cause the temperature to rise. Methane is the second most emitted, and cows emit large amount of methane, so we should have a solution dealing with cows' farts. Although cows produce a lot of methane, we still need to know that fossil fuel production is actually producing more methane. These are the major greenhouse gases. Over half of the greenhouse gases is carbon dioxide, and 17% of greenhouse gases is methane. You may be wondering, why is methane so important then, since there are 3 times more carbon dioxide than methane. But let's look at another picture. Methane versus carbon dioxide. So 1 methane can trap the same amount of heat that 23 carbon dioxide traps. That's a lot. So methane is actually a really important cause to global warming. Look at this graph. The emission of methane suddenly increased in the 1900s. In this graph, the emission of carbon dioxide suddenly increased in 1900s too, which also leads to the rise of temperature in recent years. So by looking at these 2 graphs, we can indicate that during the 1900s, as industrialization takes place, more greenhouse gases are being emitted. So now, let's talk about how scientists let cows pass less methane. Cows pass methane because the bacteria that break down the fiber and other indigestible parts of the grasses produce methane as a byproduct. Methane is not required for cows, so then they pass them out. There are many different kinds of bacteria in cow's rumen. They all work together to digest food, but the one I talked about is called methanogen, which use 3H2 and carbon dioxide to produce methane and 2H2O. Bacteria in digestive system is very important and essential. They can digest food, produce vitamins, control the growth of harmful bacteria, and break down substances that cannot be digested. So the solution to cows producing a lot of methane is to change the mix of bacteria in cow's rumen, so we can change the way how methane is produced. By changing the bacteria, we can use a method called gene cloning. But gene cloning's original purpose is to get copies of target genes by inserting them into bacteria. In this case, we're trying to change the bacteria in cow's rumen by taking the bacteria out of cow's rumen and inject the target DNA. Let's take a look at the process of gene cloning for cows. So now I'm going to talk about gene cloning. As I mentioned, in cow's rumen, there's a specific type of bacteria that's called methanogen, which creates methane as byproduct. And in order us to produce less methane, we need to change the DNA sequence in this bacteria. And by doing this, we can use the same method as gene cloning. So the first thing we need to do is take the methanogen from cow's rumen, and then we take the plasmids from the bacteria. Now that we got our plasmid, we use a restriction enzyme called E. chloride to cut this plasmid open. like this. But let us take a closer look at how restriction enzyme cut this plasmid open. So for example, if this is our plasmid's DNA sequence, then restriction enzyme E. coli will cut this open, like this, which create a sticky end. A sticky end can make sure that this base right over here can only attach to its complementary base, which can make sure the DNA sequence is right, is the way you want it to be. On the other hand, there are other restriction enzymes create blunt ends, which cut a DNA sequence like this. So without the complementary ends, this DNA sequence can attach to DNA fragments like this, or like this, which can cause errors. So the restriction enzyme E. coli will cut this plasmid open, like this, so we can leave a space for the target gene. So we use the same method as we cut down the plasmid to cut the target gene from our DNA, which also creates sticky ends. So now we can put this target gene in our plasmid by using DNA ligase that acts like tape. So this target gene can bond with the plasmid. So now we get a plasmid with our target gene, like this. Now we're using the same method that we add the target gene inside the plasmid to add another gene, which is called antibiotic resistance gene. And we'll talk about why later. So now we get our plasmid with our target gene and antibiotic resistant gene. So now that we got plenty of the plasmids that we need, we mix them with bacteria and let them undergo a process called transformation. And during this process, we can either use electric pulsation or we can use heat. So after transformation, some of the plasmids will go into the bacteria, but some of them don't. But how can we identify the transformed bacteria and the ones that didn't transform? In this case, the antibiotic resistant gene can help us. Now we can mix the bacteria with antibiotic. So only the bacteria with antibiotic resistance gene can survive, and the ones that don't have antibiotic resistant gene will die. So now that we got our transformed bacteria, we can insert them back into cow's rumen. And now, less methane are being produced. Ideally, the result of this will be that Methanogen will produce less methane as byproduct. But actually, this is just an ideal process, because scientists are still working on data collection phase. There aren't many resources that show the mechanism on the internet, which indicates that this experiment has not begun or has not succeeded. These are some advantages and disadvantages of this genetic engineering. The advantages are that less methane will be produced, and which causes a lower temperature and can slow down the rate of global warming. But there are also some disadvantages, like the quality of digestion may decrease, and it may affect the function of cows' digestive system. And this may affect the quality of beef too. These are some sources that I used during my project. And this is the end of my video. Hope you like it, and thank you for watching.